Kia ora koutou, Reese from QuickSense here, and today we're looking at stationary points. Now, a stationary point is any point of a function where the gradient is equal to 0. That is, dy of dx is equal to 0. So this function we have here, right, is already in the form dy dx equal to this. And I want to find out, well, at what point does this equal 0? Well, we can either, we're going to solve this by subtracting 64 from both sides, finding the cube root of both sides. X is equal to negative 4. Right, there's only one solution to the cube root of negative 64, which is negative 4. In this next question, we are given one of the stationary points, which is a local maximum, and we're asked to find the other stationary point, the local minimum. Now, what does this mean? Well, there are some curves which have 2 points with a gradient, dy of dx, right? dy dx is equal to 0. For this example, that happens here, and it happens here. This is referred to as the local maximum, right? It's the higher value. This is the local minimum. Now, this question is telling me that dy of dx is equal to 0. Get rid of this purple. When x equals 1. So what I'm going to do is differentiate dy with respect to x. I get negative 3a x squared. And now I know that this is equal to 0 when x is equal to 1. Just going to carry on solving this. 10 minus 4 is 6. Now I know what a is. That's really helpful because it's going to help me find the other value that gives me dy of dx equal to 0. So, using dy over dx, which is negative 3 times a, right? Substituting as a equals 2. Negative 3 times 2 is negative 6. Now, this is a good situation, right? I can have 0 equal to, I've got a common factor of negative 2. So it's negative 6 divided by negative 2 is 3. Should be an x there. Positive 10 divided by negative 2 is negative 5x, and this becomes 2. Now I have to complicate this middle value, and I multiply a and c together and get positive 6. And I'm trying to find factors of positive 6 that sum to negative 5, which are negative 3x, or negative 3 and negative 2. And that's how I complicate that, which allows me to factorize. Right, 3x goes into this x minus 1 times, and then negative 2 goes into this x minus 1 times. X minus 1 is a common factor, leaving me with 3x minus 2 equal to 0. So with this one here, x is equal to positive 1. With this one, x is equal to 2 over 3. While it would be really tempting to say that we can stop here, all right, we've got 2 answers. One of them we already know is the local maximum. The other one must be the minimum. We want to be thorough. What I know about local maximums and local minimums is that if I were to differentiate again, and I found that the answer was less than 0, that would be a local maximum. If, on the other hand, it were greater than 0, that would be a local minimum. Now that's really helpful. Let's just do an IBID there. That's really helpful because I can now sum. So if I have this here, and I differentiate it again, what do I get? Well, this is equal to -2, that's -12x plus 10. If x equals 1, then -12 plus 10, -2. Well, look, you don't have to be a genius here. -2 is less than 0. Therefore, at -1, we've got a local maximum. Well, what about the alternative? When x is equal to 2/3. When x is equal to 2/3, right, that's -8 plus 10, which is +2. And +2, again, no genius points here, is greater than 0. So here's my reassurance, right? The local maximum is at x equal to 2/3.